Lesson 15-6 is Outliers. Again, the first thing we want you to do is watch a video. So I want you to watch this video, Judging Outliers in a Data Set in Khan. And then when you finish doing that, then I want you to scroll down here, and I want you to write down this vocabulary and these two formulas. So, an outlier. An outlier is a data value that is very far away from the other data values. It can be much greater in value or much less than the other values. Okay, so they're far, far away. Okay, so for example, if you had a class of quizzes and everybody got A's and B's, so like 80s and 90s and some hundreds, and then somebody didn't study and they got a 40. That grade would be an outlier on the lower end, okay? So it's a grade, or it's a data value that is far, far away from the other values, okay? An outlier is specifically defined as a value that lies more than 1.5 times the interquartile range, either above the third quartile or below the first quartile. So if it's above, we're going to add. That's going to give us the upper limit. If it's below, then we're going to subtract from the first quartile. And I'll show you how to do these formulas coming up. Example 1A is to identify the outliers. So it says here, the lengths and feet of various bridges are as follows. We want to identify any outliers. So step 1 is to find the quartiles and the interquartile range. So the first thing we have to do is we need to put this data in order from least to greatest. So here is the data in order from least to greatest. Now when you look at this, you can say, obviously there are numbers that are far, far away, okay? But we need to prove the data, prove our answer. So step 1 is to find the quartiles and the interquartile range. So in order to get the quartiles, so that we can calculate the interquartile range, we need to first find the median. So here we have 1, 2, 3, 4, 5, 6 numbers. So that means that the median is in between here, in between those two numbers. So we are going to take 275. Oops, let me change colors. 275. And we're going to add 354. And then we're going to divide that by 2. All right, so the median is 314.5. Now we need quartile 1 and quartile 3, which means the median of the lower half and the median of the upper half. So we've got 251 is Q1, and we have quartile 3, Q3, is 727. So let's put that in our list. So we've got 251 here, and we've got 727 there. Now remember, to find the interquartile range, we are going to subtract the upper quartile minus the lower quartile. In other words, that is Q3 minus Q1. So we're going to subtract 727 minus 251. All right, so when we do that subtraction, we get 476. Okay, so now step 2 is to determine the upper and lower limits for the outliers. So here's the formulas. For the upper limit, we're going to take Q3, which is 727. Remember, these are the formulas. Now we substitute. So this is 727 plus 1.5 times the interquartile range. And that's supposed to say the IQR, not the 1QR, okay? So the interquartile range is 476. So times 476. And then we're going to simplify. And remember, when we simplify, we want to use our our order of operations. So we're going to take 476, and we're going to multiply that times 1.5. And that's going to give us 714. So we have 714 here. So we've got 727 plus 714. Okay? 714 plus 727, and that's going to give us 1,441. 1,441. Now, this is the upper limit. So, if we have a number that is higher than that, then that number is an outlier. So let's take a look. Do we have a number that's higher than 1,441? Nope, this is 1,121, so that is not an outlier. So now we want to do the same thing for the lower limit, okay? So quartile 1 is 251. So that's 251 minus 1.5 times the interquartile range, which is 476. Okay, so now we simplify. So 476 times 1.5, that gives us 714. So we've got 251 minus 714, and of course you know that's going to give us, when we do keep change, that's going to give us a negative number, right? The calculator does it for you. So 251 minus 714, that's going to give us a negative 463. So this is our lower limit. So if we have a number that is less than negative 463, then we have an outlier on the lower end. So do we have a number that low? No, we don't. So our first impression was wrong. So here we do not have any outliers. So there are no outliers. All right. So I would like for you to do the second example on your own. So press pause and then show your work and then press play again to see if you did it right. So here it says the number of calories in a serving of various fruits are as follows. We want to identify any outliers in the data set. So the first thing we need to do is put the data in order from least to greatest. Okay, so there are 8 numbers here, so we are going to have 2 middle numbers. So 8 divided by 2 is 4, so that's 1, 2, 3, 4. So that's 1, 2, 3, 4. This one, and 1, 2, 3, 4. This one. So we want to add those 2 middle numbers together and divide by 2. So 55 plus 55 divided by 2. That, of course, is going to give us 110 divided by 2. And, of course, that's going to give us 55 again. So our median is 55. Okay, so our median is not either of those 55s, but it's a 55 that is in the middle because we took the average. Okay, so we're still going to use those two. So looks like there's 4 numbers here and 4 numbers here. So in order to get quartile 1 and quartile 3, we're going to have to show our work again. So here are the two middle numbers of the bottom half, and there are the two middle numbers of the top half. So for 51 and 52, we're going to add those together and divide by 2. So we've got 51 plus 52 divided by 2. That's going to give us 103 divided by 2, and that's going to give us 51.5. Okay? Now, for quartile 3, you see if you add 60 plus 60, if you have the same number and you're adding them together and dividing by 2, then I'm okay with you just writing the answer, because 60 plus 60 is 120, and then 120 divided by 2 is 60 again. And it's going to be that way every time. If you are adding two of the same numbers and divided by 2, you're going to get the same as those two numbers. So quartile 3 is 60. So now we want to find the interquartile range. And of course, the interquartile range is the upper quartile minus the lower quartile. Okay? So that's the upper quartile minus the lower quartile, or Q3 minus Q1. So this is going to give us 60 minus, what was that, 51.5. And that gives us 8.5. Okay? So now we have all of the information that we need to do our other calculations. All right, so now we're going to find our upper limit and our lower limit. So we've got the upper limit, we've got Q3, which is the upper quartile, so that's 60, plus 1.5, so 1.5, times the interquartile range, which is 8.5. Okay, to get the lower limit, we're going to use the lower quartile, Q1, so that's going to be 51.5 minus 1.5 times the interquartile range, which is 8.5. And now we just simplify those to help us make our decision. So we've got 1.5 times 8.5, that's going to give us 12.75. So we want to add that to 60. So plus 60, and that's going to give us 72.75. And this, you guys, is our upper limit. That's the upper limit. Now the lower limit we're going to subtract, okay? So first we need to simplify. So we need to multiply 1.5 times 8.5, or we already did that, 12.75. So we're going to subtract that. So 51.5 minus 12.75. Okay, did everybody see what I just did? I put in the calculator again, but I didn't have to because I had it right here, right? So I've got 51.5 minus 12.75, and that's going to give us 38.75. So this is 38.75, and that is the lower limit. Now we can check. Do I have any numbers that are higher than 72.75? Yes, we do. Look, 72.75, there we have one right there. And do we have any numbers that are lower than 38.75? No, we don't. So the outlier here is 75. So let's write the outlier is 75, and what's my 75 calories. So we have an outlier of 75 calories. Okay? So example 2a is to describe the effect of outliers. Okay? So here we have the prices of some new athletic shoes listed below. First thing we want to do when we're trying to describe the effects of the outliers is to calculate the mean and the median with the outlier. That's step one. So since I'm going to have to do it anyways in order to find the median, I'm going to go ahead and put the data in order from least to greatest. So when we calculate the mean, so here's my data in order from least to greatest. We're going to calculate the mean first there. So we're just going to add all those numbers together and we're going to write it on top. So $366.30, and we're going to divide by, let's see, 1, 2, 3, 4, 5, 6, 7. We're going to divide by 7. So we have 366.3 divided by 7, and that's going to give us this. So the average cost of the shoe here, if I have 52.3285, so the 8 tells me that I want to round up. So it's going to be $52.33. Okay? So this is $52.33. This is the mean. So now we want to find the median. So the median, remember that's the middle number. So right now, with an outlier, and we're just assuming there's an outlier in there because we have to do it with the outlier and without the outlier. So let's see. The middle number, there's 7, so it's 1, 2, 3, and one more. There's my middle number. Okay? So I'm going to take that one out. Oh, wait, no. That's the middle number, 48.50. $48.50. Oops. $48.50. There's our median. Okay? So the mean is $52.33. The median is $48.50. So now we want to see what the effects are if we take that outlier out of the data. Okay? So now we want to calculate the mean without the outlier. So I forgot to tell you that in this problem, I was supposed to tell you what the outlier was. So in this problem, the outlier is $78.95. So this is the mean with that outlier in there, and the median with the outlier in there. Okay? So now we want to calculate the mean and the median without the outlier. So we want to subtract that out, right? So for the mean, this one's pretty simple. All we to subtract out the $78.95, we already wrote down our total here. So we're going to take $366.33. That's all of these added together. Now I want to take this outlier out, right? So I'm going to go ahead and subtract $78.95. And then now, since I'm taking out one of the data items, I'm no longer going to divide by 7. Now I'm only dividing by 6. Okay? So let's find the mean here. All right, so we're going to take $366.30. We're going to subtract out the median. So that's $78.95. And that's going to give us $287.35. So this is $287.35. And now we're going to divide this by 6. Okay, so take that, divide by 6, and that's going to give us $47.89. That's 891, so we don't have to round that up. So it's $47.89. $47.89. Okay? Now, the median. Now remember that now we don't have this, we don't have that in there. Now we've got 1, 2, 3, 4, 5, 6 numbers. So now when I want to find the median, I've got 2 middle numbers. So my 2 middle numbers, let's see, 1, 2, 3, 4, 5, 6. So 1, 2, the third number from the front and the third number from the back. So to get the median here, to get in between, we're going to add those 2 numbers together. So this is $47.50 plus $48.50, and we're going to divide that by 2. Remember, when you have 2 middle numbers, you add the 2 middle numbers together and divide by 2 to get your median. Okay? So let's see. That's $47.50 plus $48.50. That gives us $96. And then we're going to divide that by 2. That's going to give us $48. There you go. Now, step 3 is to choose the measure that best describes the center of the data. All right, so the way we decide this is we want to see how does it change the least, okay? So we're looking at the mean. First, we're looking at the mean. So the mean with the outlier was $52.33. The mean without the outlier was $47.89. Does everybody see that it came down significantly, okay? So that outlier changed that number quite a bit, right? If I'm looking at the median with the outlier, it's $48.50. Without the outlier, when I took that outlier out of there, it was $48. So if you look at the $48.50 and the $48, it didn't change that much at all. So because it didn't change that much at all, the median is the measure that best describes the center of the data. Okay? Make sure you write down your sentence. And I also want you to understand, because it's the median, because it didn't change that much at all. All right, so I want you to pause the video and I want you to do example 2B on your own and then press play to get the solution, okay? And again, this is describe the effect of outliers, and you're going to take the same measures, you're going to take the same steps that you did in the previous example. So it says the table shows the cooking temperatures for different recipes. Calculate the mean and the median cooking temperature with and without the outlier of 175. Then we want to, if we need to, we'll round to the nearest tenth. And then we want to choose the measure that best describes the center of the data. All right, go ahead and press pause. All right, so the first thing we did was we put the data in order from least to greatest. Then we found the mean and the median. Just put a line. Okay. We found the mean and the median with the outlier of 175 in there, because look, it said it here. The outlier is 175. So we left it in there first. So when we add those together and divide by 8, that's going to give us 340 divided by, 340.625 which rounded, because to round to the nearest tenth, 340.6. That was the mean. The median, we had to get the average of the two middle numbers, and they're both 350. So 350 plus 350 divided by 2 is 350. Remember I told you that shortcut, right? So that's 350. Now we had to do the calculations without the outlier. So now we're taking it out. If I take that 175 out, then I'm going to have 7 numbers now instead of 8. So here we took that total that we originally got and we subtracted the 175 out. Okay, so that's going to give us 2,550 divided by 7, and that gives us, rounded to the nearest tenth, 364.3. Now, if I looked at the median of those numbers, now that median is just that one number, which is 350. Now, when you do your comparison, you can see here that the mean changes significantly, okay? Goes from 340.6 to 364.3, so it changes. But look at the median. The median doesn't even change at all. So here, the median would best to describe this data because it changed very little or none, not at all. And in this case, not at all. Okay? So now you're going to work on your IXL, which is 8Q5. Identify an outlier and describe the effect of removing it. Okay? Remember, you must show at least 10 problems to get full credit for that work.